So this video is a review of volume, and the first thing we're going to do is review the volume definition. And the definition of volume is the three-dimensional space that an object occupies, or how much it takes to fill a three-dimensional object with water or some other substance. In this review video, we're going to be looking at how to find the volume of a cube or rectangular prism, a triangular prism, and a pyramid. The first thing we're going to do is we're going to look at formulas. The first formula we're going to look at is the formula for a rectangular prism or a cube. So the formula for a rectangular prism or a cube is the length times the width times the height. So length times width times height. And this is an image of a rectangular prism where you have the length, the width, and the height. And sometimes the length and the width can be interchanged depending on the drawing. The next thing we're going to look at is the formula for a triangular prism. The first way that we can write the formula for a triangular prism is by thinking of a triangular prism as half of a rectangular prism. I know that a triangle is half of a rectangle, so if I think about my triangular prism as half of a rectangular prism, then I can simply use the rectangular prism formula for volume, length times width times height, and then find half of it. Half times the length times the width times the height. And in your triangular prism, you have the same dimensions. You have the width and the length, and then you also have the height of the triangular piece. The other way that you can write the triangular prism formula is by using the area of the base. That is the capital B. So you can write the formula as volume equals the capital B, area of the base, times the height. Well, in a triangular prism, the area of the base is a triangle. The base is a triangle. So when you find the area of it, you have to use the triangular area formula, which is half of the base times the height. And here the small lowercase b is the base of the triangular portion. And the triangular height is from the vertex perpendicular to the base. The next figure that we are going to look at is the pyramid. We're going to look at two different ways to write the volume formula of a pyramid. The first one is to think of a pyramid as a third of a rectangular prism. Just as a triangular prism is half of a rectangular prism, a pyramid is a third of a rectangular prism. So you can write it as the length times the width times the height, which is your rectangular prism, and then find a third of that. So times by 1/3 or divide by 3. Multiply by 1/3 or divide by 3. And here your width and your length are the sides of your base, if you have a rectangular or a square base. And the height is the height of the whole pyramid, from the vertex perpendicular to the base. So this would be the inside of the pyramid. The other way we can write this is using the capital B, which again means the area of the base. So we would still want 1/3 because it's still 1/3 of a rectangular prism. And then we would find the area of the base and multiply it by the height of the pyramid. So in this case, the base of this pyramid is a triangle. So here we would find the area of the base, but it would be a triangular base, so the area of a triangle. Then multiply it by the height, which again is from the vertex to the base, measuring the inside height of the pyramid from top to bottom. And that's where we get 1/3 of the base times the height, area of the base times the height. Now we're going to look at some basic problems, basic volume problems. These are where we are simply given a three-dimensional object and asked to find the volume. So here you have a rectangular prism. I know it's a rectangle because I have the top is a rectangle, and that means the base is a rectangle, 3 by 4. And I have that it is 7 inches tall. So the first thing I'm going to do is I'm going to write my formula. And my formula for the rectangular prism is length times width times height. Then I'm going to define my variables. The length of the prism is 3, the width of the prism is 4, and the height of the prism is 7. Again, your length and your width, which are your 3 and your 4, can be interchanged. Then I substitute my values back into my formula, and I get volume equals 3 times 4 times 7. Well, 3 times 4 times 7 is 84. And since we're talking about volume, it is cubic inches. The next problem we're going to do is a basic triangular pyramid problem. So here is the triangular prism. Here's the triangular prism. You can see that I have the triangular base of 6 feet. The length of the prism, or the width of the prism, depending on how you want to say it, is 10. And the height of the triangle is 8. First, I'm going to write my formula. That's always the first thing I want to do. And I'm going to use the version of the formula that treats the triangular prism as half of a rectangular prism. So I'm going to use volume equals half the length times the width times the height. Then I'm going to identify my variables. My length is 6, so the length of that triangular base. The width of the whole pyramid is 10. And the height of that triangular piece, or the height of the pyramid, is 8. Then I'm going to substitute those values in to my equation. Half times 6 times 10 times 8. Well, 6 times 10 times 8 is 480, and then I want half of that. So I'm either going to divide by 2 or multiply by 1/2. And the volume is 240, and since it is volume, we have cubic units, and so it is cubic feet. The last straightforward problem that we are going to deal with is the volume of a pyramid. Now this is a square pyramid. So you can see, or a rectangular pyramid. Sorry, it would be square if both these sides were the same, but they're different. So it is a rectangular pyramid. So the base is a rectangle, and then it tells me how high the pyramid is from the vertex perpendicular to the base. So the first thing I want to do is write the formula. And I'm going to use the version of the formula that treats the pyramid as 1/3 of a rectangular prism. So 1/3 of the length times the width times the height. Then I'm going to define my variables. The length of the base is 9. The width of the base is 8. And the height of the entire pyramid is 7. Again, your length and width can be interchanged. Then I'm going to put those into the formula and have the volume is 1/3 of 9 times 8 times 7. And 9 times 8 times 7 is 504. And then I want 1/3 of 504, so I can either multiply by 1/3 or I can divide by 3. And when I do that, my volume is 168. And of course, we are using volume, so it is cubic meters. We're also going to review some multi-step problems. So the first multi-step problem we're going to look at is, what is the height of a box with a volume of 100 cubic inches, a length of 5 inches, and a width of 2 inches? The first thing I want to do is I want to draw it. So I'm given that it is a box. And so that's a rectangular prism. And I know that the length is 5, so I've labeled that. The width is 2, but I don't know the height. The first thing I want to do is write the formula. Volume equals length times width times height for the volume of a rectangular prism. Then I want to define the variables that I'm given. In this problem, I'm given the volume. The volume is 100 cubic inches. I'm also given the length, which is 5, and I'm given the width, which is 2. And I'm going to substitute those back into my equation. So I get 100 equals 5 times 2 times the height. Now I can simplify. 5 times 2 is 10, so 100 equals 10 times the height. Well, in this equation, the operation we see is multiplication. 10 times h, so h times 10. And so I want to do the inverse operation. The inverse of multiplying by 10 is dividing by 10. So I'm going to divide both sides by 10. And 10 divided by 10 is 1, and 100 divided by 10 is 10. So my height of the prism is 10 inches. The next problem we're going to do is a triangular prism problem. What is the length of a triangular prism with a base 5 feet wide and 4 feet high and volume of 250 cubic feet? The first thing I want to do is draw it. So here's my triangular prism. My bases are triangles, and then my faces are rectangles because all faces in prisms are rectangles. And I'm going to label the pieces that I have. I know that the base is 5 feet wide. I know that the height of the triangle is 4 feet, or the height of the prism is 4 feet. And I'm asked to find the length. So the first thing I'm going to do is write the formula, and I'm going to use the version where the triangular prism is half of a rectangular prism. So length times width times height, half of length times width times height. Then I'm going to define my variables. Well, again, here I am given volume, which is 250. I'm also given the width, and I'm given the height. Now I'm going to put those into my equation. So I get 250 equals half of L times 5 times 4. Well, now I can simplify. 5 times 4 is 20. And then because multiplication is commutative, I can move my 1/2 next to my 20. So I can find half of 20, or divide 20 by 2. And I get 250 equals 10 times L. Well, now I have an equation I can solve. I have L times 10, so multiplication is my operation. So I'm going to do the inverse operation to both sides and divide by 10. And 10 divided by 10 is 1, and 250 divided by 10 is 25. So the length of this prism is 25 feet. The last problem we're going to do that requires multiple steps is a pyramid problem. What is the width of a pyramid that has a base, what is the width of a pyramid base if the length of the base is 100 meters, the height of the pyramid is 300 meters, and the volume of the pyramid is 2 million cubic meters? So obviously a big pyramid. First thing I'm going to do is draw it. So I have a pyramid, and it tells me that the length of the base is 100 and the width of the base is unknown. Then it gives me the height of the whole pyramid from top to bottom, perpendicular to the base, of 300 meters. First, I'm going to write my formula. And because I have a rectangular or perhaps square base here, I don't know yet, but because I know it's not triangular, because it didn't tell me it was triangular, and triangles don't have a width and a length, they have height. So I know it's rectangular or maybe square. I'm going to use the volume formula that has the volume of a pyramid 1/3 of a rectangular prism. So 1/3 of the length times the width times the height. Then I'm going to define my variables. Here I'm given the volume of 2 million, I'm given the length of 100, and I'm given the height of the pyramid of 300. So I'm given one dimension for the base, and then I have to find the other. Now I'm going to substitute those values into my equation. So 2 million equals 1/3 of 100 times W times 300. And I'm going to simplify because multiplication is commutative, so I can do 100 times 300, and that's how I got 30,000. 100 times 300 got me 30,000. So I have 2 million equals 1/3 of 30,000 times W. And then I can do 1/3 of 30,000, so divide it by 3. 1/3 of 30,000 is 10,000. That's how I got 10,000 there. And so now I have 2 million equals 10,000 times the width. Well, now I have an equation that I can solve with inverse operations. Right now I'm multiplying by 10,000, so the inverse operation would be to divide by 10,000. So if I divide both sides by 10,000, 10,000 divided by 10,000 is 1, And 2 million divided by 10,000 is 200. So the width of the base of my pyramid is 200 meters. And because we're just finding a one-dimensional measurement, it is only meters. It's not meters squared. It's not meters cubed. This is the end of the video. You can work on your practice now.